Well, hello everyone, and welcome to the February 2021 edition of the St. Louis Java Users Group. For people who are new, the St. Louis Java Users Group is a pretty informal group. Attendance is free. We don't maintain a formal membership list. Normally, we meet on the second Thursday of every month, except December, when there is no meeting due to the holidays. There's just too much going on over the holidays for us to schedule a meeting then. When we meet in person, you can join us for food and social at 6 p.m. and the meeting starts at 6:30. When we do meet in person, we do it in the Object Computing Incorporated training room at 12,140 Woodcrest Executive Drive, Suite 310. I'd like to introduce the rest of the members of the steering committee for the St. Louis Java Users Group. So from left to right, we have Ted Doyle, then Todd Zimmerman, Bruce Alspaugh in the middle, that's me, Wei-Chi Gao, and Kathy Swang. The St. Louis Java Users Group would not be possible without the support of our sponsors, and I'd like to thank them now. I'd like to thank Object Computing Incorporated. They're the original JUG sponsor who has been with us since the beginning. I believe we've been around since like 1997. I'd also like to, and they sponsor the meeting room and the training room where we meet. I'd like to thank JFrog. They have been instrumental in helping us get through this pandemic. They have sponsored the meetup group registration fees. Now, it's free for you to attend, but it does cost the JUG to maintain the meetup group site, and JFrog has covered that cost, as well as the cost of this Zoom conference system so that we have a subscription and don't have to rely on something the speaker might have. They are also helping us with the VirtualJUG JUG tour, and I'll talk about that in a minute, and I'll let Ari talk about that here shortly. When we meet in person, we do have food, and that's sponsored by Signature Consultants and also by Adaptive Solutions Group. And they are headhunters. So if you're interested in finding a position, I would encourage you to contact them. And in fact, just earlier today, I got an email from the folks at Adaptive Solutions Group. Thank you very much, Dane. I'll give a shout out to you. Thank you for the $25 Amazon gift card, which we will be raffling at the end of this meeting. We will also be raffling 2 JetBrains licenses at the end of this meeting. When we meet in person, we will also raffle some gift cards from Elastic. Intertech is a training company, and they sponsor the famous Screaming Flying Monkeys. That is, they're little dolls, and if you activate them and throw them up against the wall, they scream. Oh, they're so much fun and popular. Tonight, we'll also be raffling at the end of the meeting 2 Manning ebooks, and also the folks at Pearson will often sponsor physical books for the raffle. So thank you for your support. Let's talk about upcoming presentations. I mentioned before on March 11th, there will be a FooJ.io VirtualJUG tour stop, and we will be on that tour on March 11th. If you want to know what FooJ.io is, just put FooJ.io in the address bar of your web browser. It's a new website, and they're promoting it by using a VirtualJUG tour. Our stop on that tour will be creating a Kubernetes operator in Java, and that will be by Rudy of Piera Services. And in order to make room for that stop, we did shift Melissa McKay of JFrog to April 8th. So her meeting is still scheduled to level up your Java container images on April 8th. We also have a new one uh, that is reactive microservices with Spring Boot and JHipster uh, by Matt. I believe it's Rayable. Boy, I really hate murdering people's last names. Of Okta, and I hope I'm pronouncing that right too. So we've got some good presentations coming up. So if you want to keep up with our presentations, the easiest way to do it is just point your web browser at meetup.com/gatewaychug if you want to watch the updates to the presentation schedule and meeting locations. But for the foreseeable future, it looks like we're going to be continuing to meet online the same way we've been doing. So when we do switch back to in-person meetings, it will be announced on Meetup. It will say that that will be an in-person meeting. I don't have any knowledge as to when this pandemic is going to be over, but I get the feeling it's going to continue for a while. If you are interested in giving a presentation, or if you would like to be a sponsor of the JUG, you can email all of us on the steering committee, the people I just showed, with this email address there on your screen. That's javasigsc@ociweb.com. So tonight's presentation is GraalVM for Java developers, and Oleg is here all the way from Estonia. But before I do that, I'm going to stop sharing my screen for just a moment, and I'm going to make Ari a presenter so he can tell us a bit more about this Fouché VirtualJUG tour. And so I'm searching through the list so that I can click on you to make you the host. I know you're in there, Ari. I just have to find you in this long list of people here who have joined the meeting. And oh, I see something just happened. Let me exit that full screen and let me see if I can find Ari in here. He was in here just a minute ago. Ah, there you go. I see your screen.
Yep.
And let me see.
I went ahead and I shared my screen. I had the
Oh, you have permission.
I did.
Well, remember, you're paying for this thing anyway.
There's always a back door for people like me to get into
right.
sharing my screen.
So you just go right ahead. Take it away. Tell us all about it.
I will. And Bruce, really, obviously, just kudos to you. Just listening to the introduction, obviously, it's clear that the preparation and the content that you bring into the JUG and just the whole committee really does an amazing job for the community. So kudos to all of you for that. For those of you who don't know me, my name is Ari Waller, and I am the Meetup event manager for JFrog. And I am really, really proud to be part of the St. Louis Java user group community as well. However, my community work right now is actually assisting Fouché, specifically with their upcoming VirtualJUG tour to bring awareness to the organization. Now, I'm not sure if there are those here who are familiar with Fouché. If you go to fouché.io and you look at the people that are involved in the organization, I can almost guarantee you're going to recognize many of these names in the Java community. So I'll leave it there for the moment. But in a nutshell, Fouché is a community place for friends of OpenJDK. And it's also a user-focused community that is committed to bringing technical dashboards and updated data to the day-to-day Java developer, which I assume many of you are. There's a lot of other resources they have available. Community Slack channel that's free, updated, and also updated blogs on the cutting-edge items that are taking place in the Java community. So it's really, really exciting. As Bruce said, we have a tour that's going to be actually stopping in 17 different areas of the globe over March and April. So the great thing about this tour is that we're not having any of the Fouché speakers repeat any topics on the tour. So we encourage people, especially in this virtual world, to actually pretend it's the Grateful Dead and follow the tour across the globe. And it will be just a great experience for all. But as Bruce already mentioned, Rudy's going to be here next month speaking on creating a Kubernetes operator in Java, and I know that's going to be a really interesting topic. for you. So we're really excited about this. So I'm going to put on my JFrog hat now and just tell you just a little bit about JFrog. I'll switch it down. So this is one of our core values at JFrog is community happiness, and sometimes we like to go out there and put a raffle out there. But before I get to the raffle, just a little bit about who we are at JFrog. We are a DevOps software company with a love for Java. You may know us for our flagship product, Artifactory, which is written in Java and is used by millions of developers and operations engineers across the globe. But what a lot of people actually don't know is that Artifactory and the JFrog DevOps platform are actually now available as a free cloud subscription, especially for the community. And there's no credit card required either. In addition to managing your artifacts and dependencies, our free tier includes the capability of serving as a proxy cache for Docker images you need from Docker Hub. And here's the best part. I'm not sure if you heard about this, but we just announced a partnership with Docker. So by using the JFrog free tier, you'll bypass the Docker Hub rate limits for anonymous access. So if you're familiar with that issue, there's a huge advantage to checking out the free product. But back to the raffle. So tonight, we are going to be giving away one of my favorite things. If you look behind me, you'll see a lot of Star Wars Legos, and thus I get to influence the prizes that we give out. Here's Baby Yoda built. He's one of my favorite Star Wars builds. And who doesn't love the little guy? It's very difficult to find Baby Yoda in the store. So let's say you hate Legos, put it up on eBay. You're going to make some. You could probably make some money too. He's selling above. He's selling above the market as well. But we are going to be raffling this off. Our raffles are a little bit different for corporate compliance purposes. So a winner is going to be selected in 24 to 48 hours, and we're going to contact that winner via email. But once we establish the ability to be able to give them the prize, they are going to go ahead and announce it to the St. Louis Jug community. So you're all aware of who that is. So you can just use the QR code, the bit.ly on the bottom, and I'm going to drop it in the chat a little later. So you'll see it there. But again, just really, really excited to be part of the community. I took longer in my introduction than I wanted to, but I had 2 organizations this time, and just really, really exciting to be part of this jug. So Bruce, I'm going to turn it back over to you.
Okay, thank you, Ari, for all the prizes and allowing us to be on that virtual jug tour. I appreciate all the things you've been doing here to help us out. So I think we're ready for tonight's presentation. I'm going to right-click here on Oleg and select the Make Host option. So with great power comes great responsibility, but I'm sure you can handle it. And I see your screen right there, Oleg, all the way from Estonia. And I happen to see a GraalVM presentation that he gave about a year ago at DevNexus in Atlanta, right before the pandemic started. And I had been wanting a GraalVM presentation, gosh, for the past year. So Oleg, you are actually making history right now, believe it or not, for the St. Louis Jug. How is that? You are the
That sounds awesome.
Yes, you in the entire history of the Jug, going back to 1997, are the first current Oracle employee to give a St. Louis Jug presentation. And that even goes back to Sun Micro before that. Not that we haven't tried, but it's great that we've broken down that barrier. So why don't you take it away here, Oleg?
Yeah, right. I'm very grateful and honored to be here. Right, I hope you can hear me well. Can you tell me if the levels are fine and like?
I can hear you just fine, Oleg.
Excellent, very, very good. Right, so my name is Oleg. I do indeed come from Estonia. I work as a developer advocate for the GraalVM team at Oracle Labs at Oracle. Oracle Labs is a research and development institution within Oracle. So people who work there actually do quite a bit of academic work that is powering then the future research and is transformed into the products for the greater community and the products that people can use in the industry, right? So people investigate how to better solve the problems that we have in computer science, how to do stuff that we didn't know was possible before, then write academic papers about that, establish experiments, right? Like they do proper science, which is very cool. I don't think very many people realize that such a team within Oracle exists. And one part of the programming languages group within the Oracle Labs is kind of very strong. So programming languages research, if you're interested in that and read academic papers, you for sure will see names from Oracle Labs. So that's where the GraalVM as a project comes from. I want to keep this casual, right? So if you have any questions, and I'm sure you will have the questions throughout the presentations, you can just ask me. I think this is fine. You can just interrupt me. We're not at the unmanageable amount of people, so we will handle that quite nicely. And if not, you can find me online. I almost universally go by @Šelajev on various GitHubs, Twitters, and so on. I think I even have TikTok if anyone not using, but I do have a username there. Right, so let's go. This is a technical presentation, so do not make any forward-going business decisions based on the contents of that. And know that the GraalVM native image technology that we are going to talk about is available under the early adopter technology license. So be aware of that. Right, with all that necessary stuff out of the questions, let's talk about the technology. Let's talk about GraalVM. I hope many of you, or at least some of you, have heard the name of the project. We've been trying to be very active in the last couple of years in the ecosystem, trying to educate people about GraalVM and what it can do. If you're not, then a very quick one-sentence introduction of what GraalVM is. It's a high-performance, embeddable, polyglot virtual machine that is capable of running programs in different languages. So we support currently quite a set of programming languages, including the JVM languages, of course, JavaScript support, Python, R, Ruby, WebAssembly, and the LLVM bitcode. So that is quite a diverse set of programming languages, and you can run programs in those on GraalVM. There are three main promises that GraalVM does, and they were kind of reflected in that one-line statement. So there was a high performance, there was embeddable, and there was the polyglot. And from that come the actual virtues and the benefits, what you can have when you use GraalVM. We're going to outline those, and then throughout the presentation, I would like to concentrate on the JVM languages specifically, because this is a Java user group, right? Java user group. So we are mostly going to talk about Java. And when I say Java, like I use this term a little bit loosely. So anything that compiles to Java bytecode, right? Anything that runs on JVM, we're going to call that Java. So if you're writing Kotlin, or if you're writing Groovy, or if you're writing Scala, or if you're writing the extent, or if you're writing any other number of JVM languages, we're going to call it Java, and the whole argument still stands for your language of choice. So I will be sharing the deck and the slides a little bit after. I don't have this actually online yet, so you will have a chance to look at that later, but currently just keep with the program, so to speak. So one virtue and the most straightforward application of GraalVM is to get a better runtime for your JVM applications. GraalVM includes a state-of-the-art optimizing JIT compiler, the just-in-time compiler that will eventually kick in when you run your Java application long enough. And then the better just-in-time compiler manages to produce better machine code and your applications run faster. So in GraalVM, the just-in-time compiler comes from the GraalVM project, and it's really, really good. The second benefit is the native image technology. This is sort of an ahead-of-time compiler for your applications. You can take your application, you can compile it, you can process it with the native image utility from GraalVM, and it will output the native binary for your platform. So that it will be an executable file or a shared library, but normally an executable file that you can just double-click and it will run, and it will exhibit a different performance profile. And in some use cases, in some scenarios, that is absolutely exactly what you want. We're going to cover those two in much, much greater detail through the first half of the presentation, loosely 80% of the presentation, because those two give the most value to typical Java developers working on the normal Java projects. And then, but the third virtue is the polyglot runtime. That means that in the same process, in your Java application, you can also run code written in other languages. So that means you can build a system where different components are written in different languages, which sometimes confuses people a lot. And they look at this picture and say like, oh my God, like this would be a mess. This will be unmaintainable. I don't want to write anything in R. I barely know R. I don't know R. Maybe some people hear about R for the first time, which is a very confusing idea, right? The fact that you can doesn't mean that you have to, right? You don't have to. You can use and run on GraalVM programs in a single language, the same way that you would run on the corresponding other runtime. So like you can run just the Java application, or you can run maybe a Java application with some Python on the side to do machine learning, or I don't know, some Ruby on the side to do something very dynamic, or some JavaScript on the side to offer you users to customize the execution of your application somehow using JavaScript. So you don't have to mix all the languages. You can just say mix two components, two different languages for different components. And obviously, as a rational human being, you could be choosing exactly languages for the components where, like components for the languages where they excel at, right? So machine learning normally means Python these days, so that could be a good fit. So this is what GraalVM can do. There is also a user story and the use case for embeddability, but that mostly is handled by this and supported by this ahead of time compilation, where you can build the GraalVM technology into the shared library and then use that from within like a larger either Java or native application. This way, it's very curious. Recently, there was a release, and the Oracle database in the recent version can run JavaScript code inside the database as you would run a stored procedure, but you can run JavaScript code there, and that JavaScript code is executed using the GraalVM technology, which is kind of very cool. Right. We can talk more if we have time and if you have questions about any of those particular use cases, but let's start with the general overview and then go into the performance aspects. So recently we published what we call the GraalVM quick reference, which is a very good resource, and I think we're going to do more of those throughout the year. So if you go to the medium.com/GraalVM, where the GraalVM team blog is residing, you can find the GraalVM quick reference, and this is one page sort of cheat sheet, which outlines the main commands and options that you can use and would like to use for GraalVM, right? So the GraalVM quick reference goes through exactly Java applications, native executables, and polyglot programming. There's also a specific one on the compiling native executables and so on. We're going to do more. So if you want a quick reminder, or if you have an office with walls and everything, you can just grab a version, print it out, and put it on the wall. I think it would look there very nicely. Right. Java applications. What GraalVM? How can GraalVM run Java applications? There are two normal modes of execution, one with the JIT, one with an ahead of time compiler. With the JIT, this is the most normal execution of your Java application. You can take your Java files, you can take your jar file, and you just run Java from GraalVM, and it will run in the context of the OpenJDK. So it will run the Java hotspot virtual machine as an underlying VM. And it will replace the top tier optimizing JIT compiler with the GraalVM one. It will do exactly the same thing that hotspot does, and it will exhibit the same performance profile. Just due to the JIT compiler, the peak performance could be better and could be significantly better. And then let's keep AT out of the questions for now. We'll come back to that later. So what does it mean that you run on GraalVM? So as I said, the Java hotspot VM starts, and this is a native application written in C, written like it's a native precompiled application, right? And then it starts, and then it is ready to execute your Java code dynamically. The GraalVM compiler, which is an essential piece of this picture, integrates with the Java hotspot VM using Java virtual machine compiler interface. This is the established and the official interface for supplying third-party compiler into your Java hotspot VM. So if you would like to write a JIT compiler, you would implement the JVM CI, and you can provide your compiler. That's how the GraalVM JIT compiler integrates with hotspot VM, and this is what we enable in the GraalVM builds by default, right? So GraalVM contains a compatible JDK based on OpenJDK, and in our builds, the compiler is enabled by default and is there. Through those two bottom layers, we can run the Java applications normally, right? So anything that compiles for Java bytecode can go there. The hotspot VM will find load classes, verify the classes, start executing them, interpret the code, and so on, right? For the other languages, we need additional infrastructure because other languages do not compile to Java bytecode. And sometimes it's very awkward to try to compile languages to Java bytecode because they can be very expressive. And then when the language changes, you will need to maintain this whole infrastructure of the compiler. You will need to do certain optimizations on that level because like a more expressive language compiled to the low-level language like bytecode would lose some interesting semantic properties, and you will have to do a lot of work to make that right. That is how, for example, Nashorn, the JavaScript engine, was implemented in OpenJDK, and it was for a very long time stuck at a sort of ancient now version of JavaScript that is supported, and it could move forward because that was quite a bit of work, because you had to re-implement the whole compilation thing and the VM for the new language features. So GraalVM doesn't do that. GraalVM's approach for the languages is that there's this thing called Truffle framework, which is a framework for implementing managed languages. And what it does, it provides you API to create the interpreter for the particular programming language using Java. So you fix the semantics of your target language. So you fix the semantics of JavaScript by writing the high-level interpreter in Java, which has like quite some benefits. First, like we love Java, right? Java is great. Java can have its quirks, but it's a high-level language. It has the tooling. It has the unparalleled ecosystem. The best part of that Java developers understand Java and can write Java, right? This is what we do daily. So you don't have to switch the language when you need to go at one level deeper and support like a language runtime, which is a very, very big plus. And the second big plus is that you only need to implement the interpreter. So you don't actually have to figure out a way to translate the concepts in your target language, right? For example, I don't know, Ruby closures or something, or Python list comprehension. You don't have to figure out how to translate that to bytecode or to the lower level machine code. You just have to describe that using Java and using the normal APIs. So for example, a list comprehension in Python could be described as a maybe like a sequence of stream operations or something, right? Without actually producing bytecode for that. And then at runtime, the truffle framework will execute this interpreter and it will start evaluating the program in your target language. And then it will compile this interpreter in a very specific and interesting way. That is called a partial evaluation. It will sort of inline the program into the interpreter, despite them being like in different languages, right? And then it will create this specialized version of the interpreter that is really, really good just for this one program. And then it will pass all of that to the JIT compiler, and the JIT compiler will optimize it further and then produce really good quality machine code. So the execution of those languages is actually really fast. And you can see there, we have the LLVM bitcode interpreter as well, codenamed Sulong, and through that we can run native code on GraalVM. So if you want, you can run Doom, for example. There are actually many ways to run Doom on GraalVM, but the most straightforward one is to take Doom, compile through LLVM, take the bitcode, run it on GraalVM with Sulong. So this is what the current what do you call that? The bird's eye view of what's happening at runtime when you execute the programs. And it sounds really good. And it's actually is very straightforward, right? Because it uses the same infrastructure as your normal Java programs. So you can get used to that you can start using that very, very easily. How to start using that? You can download GraalVM. For that, you go to the website and you download the binary. That is an archive. You unpack it, you unzip the thing, and then you put the GraalVM directory on the path. I mean, like the bin directory within GraalVM distribution on the path. And then that one includes Java utility because it includes the normal JDK distribution. So you are good to go and you can run your Java applications just like that, right? So you can literally download the archive, swap the path in your deployment thing, and your application can potentially run faster. How much faster? This is an interesting question. And what does it mean? Here's a little benchmark, and this is a synthetic benchmark. So take it with a grain of salt, right? Like whenever someone shows you benchmarks, you know that this is I'm not going to show you a benchmark where my technology behaves poorly, right? I'm going to show you an interesting use case where it behaves well. But this one is very synthetic, but it outlines a very important quality of GraalVM and the power of the compiler. Is it that it is really, really good at seeing through abstractions in the code, right? So here's the benchmark. It's very simple. We would like to compute the hash function of some fields in an object. And we have two versions. One is raw, where we just take the fields individually and we multiply them by 31 and add together the result, which is sort of a normal way to compute the hash code of the multiple of the fields. And that is the raw version. And there is the abstracted version where we call the objects.hash method and pass those fields together, right? So they're a little bit different, and the actual computation that happens is the same, right? So object hash will call something else, and that will call something else. But in the end, the fields will be multiplied, the values will be multiplied by 31 and added together. So the actual computation is the same. I, as a developer, would absolutely love to use the abstracted version because that is easy to write, it's easy to read, right? I can immediately understand what it's doing. But for some reason and for a long time, we were writing like code that is easier for the compiler to optimize because, well, the compiler wasn't really good enough to maybe process more abstract code. So the GraalVM's vision is that the abstractions should come without regret. Right. So as developers, we should write code as we would like it to write and read, rather than trying to optimize it manually for the VM to execute. So here's the poll, and this is not the actual poll, but we have the chat. So we have the chat. So if you are still listening, if you're still with me, I would like you to type 1 or 2, depending on which one do you think is closer to being the correct and true answer. The performance of the abstracted and raw, or to those versions, is approximately the same. That is one statement. And then the other statement is the raw is significantly faster than abstracted. And significantly, say like 10%. 10% is a decent speed up, right? So 1 or 2, same performance or raw faster. Oops. Right, so here's the benchmarks too. Right, we see quite a bit of 1s, quite a bit of 2s, which is very good. This is the best situation, because this way I can say that all of you are correct. Or to say that all of you are incorrect, depending on the mood. Right, so let's see and let's investigate. Actually, I have my console here, and you can see that. Can you see that? Can you see? If you see that,
yes.
Well, just tell me. Very good. Right. So here's my Java. Right. If I do which Java, it comes from GraalVM, and if I do Java -dash version, like true old school Java developer, not using double dash version, here you can see that it is a build based on GraalVM, and this is my Java. It's on the path. Right, it's on the path. So when I run Java applications, I will get my GraalVM Java here. So I will cd into the object hash benchmark thing, and I can show you that this is exactly the same. Wait, main, yes, Java, IO control flow, object hash benchmark. Right, this is my benchmark. It's exactly the same, like 3 fields, abstracted, raw. And there is a large comment here at the bottom, which I actually cannot see. Profiles. Wait. Profiles, open profiles. Let me just make it edit profiles. Want to make it what window, opacity, transparency, no transparency. Very good, very good, very good. Go back. Right. So you can see, so here is what the abstracted version does. So it's a hash, it takes the var args, it passes the arrays hash code, which takes an array. So there's an array creation, then there's a null check, and then we iterate this array, and then do actually like the multiplication by 31. So quite a bit of like the wrapping code that is allocating array and null checks and whatnot, right? So I'm gonna run this benchmark on, so I compiled this. So there is a benchmarks jar, and I will do SDK list Java. Wait, I don't want to use my, I don't have any other Javas. Right. I will use my GraalVM Java, but I will disable the GraalVM compiler. Right. Minus use JVM compiler. So this way, the normal OpenJDK setup will run, right? So it will run with everything, and the top tier compiler will be still C2, which is the default compiler in OpenJDK, right? Target slash, no, I need minus jar, right? Target benchmarks jar. It will run for a minute. And we'll see the differences between the abstracted and the raw version of the execution, right? So this is the benchmark for throughput. So we're measuring how many operations can we do in a microsecond. So here, higher means better. And we're warming up for 50 seconds, and then we'll measure for 50 seconds. You can see the numbers. I'm running this on a cloud machine, which is a sort of a decently powerful VM with quite a bit of CPU, quite a bit of cores, quite a bit of RAM. So if I SSH there again, and just while the benchmark runs, I want to show you htop, right? So I have 16 threads there, and I have 100 gig of RAM. I like this cloud VM quite a bit. I use it as my workstation, right? And while the benchmark runs, the off topic, I have my demos set up there. I have my IntelliJ IDEA set up there, and I'm just using the face UI for it. So it's kind of a cool setup. I'm actually using this as my workstation because my poor MacBook has like something like not a great processor, not a great CPU. And it has like when Zoom takes one thread and when this Zoom screen sharing takes another thread, then they run some Java application and it just doesn't refuses to compile at runtime because there is just not enough resources to actually run the JIT and the GC like in the background of the Java process, which is kind of unfortunate because I love to run like a ton of stuff through my laptop. And for that reason, I had to move out all my demos to the cloud, which is actually a cool setup. Like I could do probably a session about that. But right, let's get back to this, right? So we're running our benchmark and we can see that the abstracted version was running at approximately 28, 29 operations per microsecond, right? And the raw version runs quite a bit faster. So it starts at 147 and then it warms up to be like almost 170, which is like 5 times faster, right? So the raw version is 5 times faster than the abstracted version. So people who typed 2 in chat were absolutely correct, right? And people who typed 2 in chat would probably spend their time writing code like in this lower level way to satisfy the compiler and satisfy the runtime, and then happily go back home knowing that they did a good job and the code that they wrote will run fast. So we have 28 and 167. So they were correct, which does mean that people who typed 1 are incorrect. If I run the same thing, but I will not disable the GraalVM compiler, right? I will run it as normally I would run Java applications on my GraalVM, and it will run, and it runs, and it will do the same benchmark just again. But even after the first like 10 seconds, so however the iteration is, we can see that we're running the abstracted version of the benchmark here, right? And we can see that even like in the first warm-up iteration, we get to the same 167 operations per microsecond as we had in the raw version when we used C2 as our JIT compiler, right? So I will let this run because it's actually interesting, but this is the point, right? GraalVM compiler can see through the complexity of the abstracted version, can see through the allocation of that array, can see through the null checks and the iteration of that array, and remove all that unnecessary stuff, and literally produce the very similar code for that higher abstracted version as it does for the lower level version that actually spells out the computation manually. So you don't have to actually unwrap your computation and specify it manually. because you can just write code the way you want to write the code. And the compiler is sophisticated enough to actually optimize that execution very, very well. And of course, at a certain level of time, like when when piling up the complexity, right? When you are adding more and more stuff on top of that, eventually you can get to the complexity of the program that will just cannot be optimized to the same level, but very usually does a really, really good job. The reason for that is, the reason for why the compiler is so good are several, right? One, and we cannot deny that, right? So well, one is a very good compiler, right? A lot of work was put into that, but it's also sort of like a second rewrite, right? So we definitely learned from how to write JIT compilers from the C2, and the second rewrite usually is more successful, right? But also GraalVM compiler was the first component from which the research has started, right? So the GraalVM project, like 10 years ago when the project was starting, it started with the question, can we write the compiler using the high-level language of Java? Normally because the JIT compilers are written using C or like some other native languages, right? And that is not ideal for Java developers, right? Because Java developers would rather use Java. But normally it was 10 years ago, it was seen as not ideal, as Java is not an ideal choice for such kind of work. And there was some research about how to do that, right? So, and then 10 years later, now we have a state-of-the-art compiler that is probably the best just-in-time compiler that you can get for your JVM. Right, so we can see here that the abstracted and raw version are performing equally well, and they're performing actually equally well as the raw version of when we ran with C2, right? So there is no performance penalty for running the code that is written in the way that we would like it to write and read. Right, so the compiler is something like 9 years old now, right? So it's a mature project, and it's battle tested. We run a ton of benchmarks, we run a lot of tests, we run a lot of software in that. We run just like software from the wild, right? To test that it runs well. And we know that it is running well, correct, and fast. So this was just a small demo that the compiler is indeed decent, right? And it actually offers the performance boost, even if this is a synthetic benchmark. There are a number of high-level optimizations that is really good in the GraalVM compiler, right? So some of them are and include. So our inlining is really good, right? Our escape analysis is really good. So escape analysis is where the compiler can not allocate the object, but instead operate on the fields of the object as if they were just, for example, like a bunch of variables. That reduces the pressure on the GC because you don't allocate the objects, and it allows more and better other optimizations to run. So it's a very big deal. The polymorphic inlining, which is when you use interfaces with different implementations, is really good. So that allows the collection library, which is literally like a bunch of interfaces with a ton of implementations, runs the collection library code runs really well. And those high-level optimizations are helping quite a bit for the compiler to be really good. So even if like at the low level, the last transformations, I don't know, like the register allocation or something like that, it might not be state of the art or excel or be the best, right? Being really good at the high level optimizations that are just produces the incredible results. And the incredible results are something like this. right? So we run a ton of benchmarks, but one benchmark suite that we like to recommend is the Renaissance, which consists of the benchmarks from different projects, that we currently use in the ecosystem quite a bit. So there are some Project Reactor benchmarks, and there are some Neo4j benchmarks, which is the graph database, and there are some I don't know, there was some Scala thing, Dotty, I think there's a Scala compiler. There's some Akka, which is the actor-based framework. Right? There was some math and everything. So there is actually an academic paper about the benchmark suite, and all the benchmarks were picked up to exhibit different behavior. Some of them are data intensive, some of them are computation intensive, some exhibit parallelism, some exhibit parallelism in data, some exhibit parallelism in the computation. So like different styles of how you can stress your runtime. That's how the benchmarks were picked for the suite, and they all come from the projects that are currently active. So there are chances that if you're writing code currently, right, it is probably not like the same code as you would write Java like 15 years ago. So if your benchmark suite comes from 15 years ago, right, it can only test the code that like how we wrote code 15 years ago, which might not reflect the actual current state of how we write code today. That doesn't mean that we don't run those other benchmarks. We do run them, but I like Renaissance, right? And more benchmarks are good. You have to be careful with conclusions because you don't want to like optimize for the benchmark specifically, but all benchmark data is interesting. So what you can do, you can try actually GraalVM on your workloads, which is fairly simple to do. You can just download, unpack, and if you have performance tests, very good, just run them. If you don't have performance tests, you can maybe create some synthetic performance tests for your application. I don't know, just load some certain pages with like JMeter or something and just see how it works. Yeah, and that's good. And also, besides being just good, right? So GraalVM is a few years now we have the public releases. Besides that, GraalVM compiler is also getting better and better every year. So for example, this is the last year. So 19.3 was released in December of the 2019. The 20.3 was released in December of 2020. The average improvement on the number of benchmarks, and those are like Spec, JVM, and Da Capo, which are like very established industrial benchmarks, and Renaissance, the average improvement between those two versions is about 6%, right, in a year. And like mine, like you have to like very important to stress out here is that like the baseline here was not like a lousy execution. It was state of the art. It was the fastest like back then, right? But it got even faster like a year later. So it's very easy to show relative improvement when you start with something like with a poor performance, right? If I don't play any musical instruments, if I would pick violin or something and then play consistently for a year, next year relatively I will be like much better than I'm currently am, right? Because currently I'm just like very bad at that. I assume maybe I'm a genius and I would just produce excellent music from the get-go, but probably not, right? So, but if I'm already really good, like GraalVM was last year, right, or 2 years ago, then improving is a very big deal, even if it's something like 6% is actually a terrific result. Right? I think 6% is 3 monthly salaries in 4 years. So this is nothing to be ashamed of. If you don't want to take 6% performance improvement in 4 years, I would argue that you should wire me 3 of your monthly salaries, because that is something that you can absolutely ignore, right? I don't want your money, but that is an illustration there. Right, so this is good, the compiler. You can just run it and be done with that. Performance is good, compiler is really great. By the way, it's written in Java, so you can see the source for the open source version, all good. Let's talk about AOT now. This is the second aspect, and this is probably even more hyped than the GraalVM for performance reasons, right? When we talk about performance, one main thing is that very often we talk about different things. So there are different axes of performance, and these we gathered from what people mean when they say, oh, I have like this runtime has better performance than that, or this language has better performance than that. So there is peak throughput, there is a latency requirements, there is a startup speed, there is a memory footprint that people care about. There is packaging, which to me sounds surprising, but like people care about that, so it is here. And normally the runtimes with a JIT optimize towards the peak throughput and the latencies. This is very understandable because the JIT needs some time to warm up. The JIT needs some memory and some resources to actually, well, you have to run the JIT, right? For that, you have to run have to take some CPU. It has to manipulate some data, which would probably be like a rather large graph of the program. So it needs some memory for that. So those axes will not be as maxed out, but the peak throughput can be very, very good. And obviously the latency, which is normally the reverse of the throughput, can be also very good. There are other factors that can influence latency, for example, the GC pauses and so on. But in like on the napkin math as here, right? If you have good throughput, you have really good latency, unless something unexpected happens, right? The ahead of time compiled version of the program would exhibit probably a different performance profile. It will probably start really, really fast because it's compiled. There is no compilation needed. It's ready to do business. It will probably have lower memory footprint because it doesn't need to do jitting, right? It doesn't need to actually manipulate the source of the program in, like, say, the bytecode form, or like create graphs and then like see which optimizations are needed or necessary or possible, right? It can just, because it's all compiled, right? It can go, and it doesn't have to allocate the resources for that infrastructure. So you can literally have mostly your program that is running and not the additional services of the runtime. And it probably will be smaller in the packaging department because it can probably efficiently strip the unnecessary parts. So the good thing of this diagram that you can, like in some use cases, some deployments, you prefer the low memory footprint and startup. Like in the cloud, when you want to scale to 0 and then make your Kubernetes manage your services for you, you want them to start up fast, and then you want to like cut your resources into the small containers, like, you know, like 500 megabytes RAM each, and then say like, oh, you need an application that does X. You want my user like or movie recommendations service, right? Like just start one up. Here's the container for you. Take 500 RAM and just go with it, right? You cannot do that for the application running with the JIT because, well, it will start slow and then probably might not fit into this small container. And some applications you want to run with a JIT. So the good thing is GraalVM offers you the choice. GraalVM offers you options. As a developer, you can say like, oh, I want to run this with a JIT, or, oh, I would like to run this in the pre-compiled mode, right? This is where this second arrow comes back, right? And the important part here is you can see that you feed your classes to the native image utility, right? This is one step. This is one part of the life cycle, building native image, and it will produce you an executable, and then you actually run that executable, which is the second part of the life cycle, right? And those two doesn't have to be like near each other. You can build your executable in one place and then run it at a later time, for example, in the cloud, in your Kubernetes cluster. How does it work? The most important philosophical thing that you have to understand there is that the GraalVM native image is built under the closed world assumption. That means that all the bytecodes that will ever be executed have to be seen at the build stage. When the native image utility runs and when you feed it the classes, you have to feed all the classes. So there will be no loading new classes at runtime. That is a trade-off, right? It allows us to do very aggressive AUT optimizations. It allows us to remove the unnecessary things quite aggressively. So if we know that this certain class won't be actually run, we don't have to include that. It will allows us to limit the overhead for the infrastructure even further by not including, for example, the bytecode interpretation facilities, right? Because there are no new classes and all the existing classes are pre-compiled. So we don't need to have like anything that understands bytecode there. So that gives us performance. The dynamic parts of the language need configuration because the analysis that performs this closed world is static, means it doesn't run the application, right? So if you use something that is dynamic and that is creates stuff from strings, for example, like reflection or like resources, when you say like, oh, class loader get resource my JavaScript file, and you pass the string of the name of that, right? The static analysis cannot determine which files do you actually mean because it could be like prefixes or you actually pass only the string. So you need the configuration to say like, oh, I'm gonna have the proxies for my Hibernate models and I will use the JNI here and there. And then those are the resources that I want to include and some reflection. So those are the important things. There is a trade-off when you build the GraalVM native image. How it works on the more not philosophical, on the like bird's overview, what happens when you run native image utility. It takes your application, it takes the libraries, it takes the dependencies, it takes the JDK classes, it takes the components of the runtime, such as GC that come from the substrate VM project within the GraalVM. All those things are written in Java, right? So Java class library, dependencies that have applications, those all Java bytecode. The components of the runtime, the GC namely, or the thread scheduling or something, are also written in Java. So all that part on the left is Java, the Java bytecode. So then it can look at that, statically analyze what is used, and then initialize the application. Meaning it can look at the classes, it can compile the classes, it can prepare the classes, and then it takes the sort of a snapshot of your application and compiles the code and writes out the data that was pre-initialized and puts that into the executable, right? And that is the essence of how the native image works. It takes Java from one side and it outputs the native binary on the other side. And that binary includes some data that is pre-initialized, and it includes the code of your application that is pre-compiled. And that code is all the code that will ever be executed. So there's that executable doesn't deal with executing Java dynamically, right? So which is really good because it gives you performance. It gives you the lower memory usage, and it gives you also some security implications, which is actually we don't talk much about, but security implications are kind of interesting, right? Because the code that is not there cannot be vulnerable, right? It cannot be exploited. If your application doesn't use, for example, deserialization, and if your application like doesn't deserialize objects, and the code that is pre-compiled and put in there, it just physically doesn't know how to deserialize the objects or how to deserialize like a random class in like one of the dependencies that you have that will be used to like exploit further, right? It just physically cannot do that. Your application is not vulnerable to those types of attacks, right? So native image could be a way to reduce this area of vulnerability for certain types of attacks and exploits, which could be very interesting in some contexts. But back to performance, right? Here we have the yes, we have the AAT and the JIT examples. It's a Micronaut web application microservice. We run 3 requests to it, sleeping 1 second between each request, and then we record the CPU usage and the memory. You can see that on the right, we have the JIT, and it does quite a bit of work. There is quite a bit of red, which means CPU. And it does a lot of work at the beginning. In the beginning there, you can see that the first blob of red. When the JVM starts, right, it starts using memory, right? The blue line goes up, and it also starts using CPU that initializes some things. It like prepares stuff. It loads the classes and so on. Then the VM gets ready, and then around 6 seconds it was ready to serve some requests to me, and then we started hitting them with requests, and then there is serving a request means that the new code is triggered, right? The new code is running, so the CPU spikes again because that triggers the facilities for the JIT and everything. That needs to start processing that code as well. So the memory grows even higher, and then kind of the stays on that level for those 2 additional requests that we did. In the AAT example, you can see everything is precompiled, so the CPU just spikes only when we actually serve the request, and the memory sits at something like 30 megabytes, which is astonishing for a microservice written in Java. Have you ever thought about that? You can write a Java microservice, and it can, this is a simple one, right? This is a hello world or something, but it can run something, the actual, like the native like HTTP server, and then some application on top of that with dependency injection and everything, right? and that thing can run and consume less than 35 megabytes of RAM. I think that is absolutely inspirational and opens new possibilities, right? The ecosystem for that is actually maturing every day and every year. So back when we announced that this is a possibility in 2018, 2018. Oh, that was a good time back then. Right. Then there were more rough edges around that, and the configuration was a little bit harder and everything. But now there is a support from a number of frameworks. There is Micronaut, and the one entity behind Micronaut is object computing, which is I heard has some connection to the JUG here. So those folks are developing Micronaut. There is Helidon from Oracle. There is Quarkus from Red Hat. There is Spring support is coming. The people are working on that. The Pivotal team is working on the support for the Spring applications for GraalVM. The GraalVM team is also working in collaboration with those folks at Pivotal. So it's shaping up to be like actually really, really good and working. Quite a bit of stuff actually works. So if you're interested, actually another time for another poll, if you're still with me, can you type in, like if you're using like a framework for your like applications or something like the, just drop the name into the thing, right? Into the chat, what you're using. If you're using Spring, say Spring. If you're using something else, say something else. This is just for me to like, it's not an official poll or anything. It's just, I love to see what people are using here and there. After we're done with this, I will ask another question. And there is also Pico CLI, which is an excellent command line, a library for writing command line applications, right? It provides you with like argument parsing and the colored output and this and that. And then you can use that in conjunction with, for example, Micronaut or Quarkus for dependency injection and stuff, right? But it gives you the command line application kind of developer experience. Very excellent. Love that very much. Right. So we have quite a bit of Spring. Someone who's like capitalized Spring. A big fan of. I see one Quarkus as well. Very good. One Wildfly. While we are in the chat and you have the chat window open, type in the version of the Java that you're using for production. Right? Like 8, 11, 15, 16, if you're brave. I expect mostly 8 or 11. Mostly 8 and 11. This is what we usually see from the community. And luckily for you, GraalVM provides distributions based on 8 and 11, so you can just switch by downloading an archive. You don't have to like jump through hoops. Right. The startup time of applications written and processed with native image is milliseconds, literally, like a few dozen of milliseconds, kind of the same way as the startup of the native applications. And the thing here is, the most important part in this graph is that the results are a little bit different for all the frameworks because they do things a little bit differently, right? But after they're processed with native image, the startup time goes very close to zero, right? It goes to the milliseconds, and the difference between the actual, like the startup time on the JVM versus using GraalVM native image is much larger than actually picking and choosing between different frameworks, right? So this is the important bit, right? And then memory footprint gets kind of sort of similar, and this is for the hello world, of course. But if your application actually initializes a lot of data and then like processes that data still needs to be initialized and still needs to be processed, so your memory consumption will be larger. Like if you allocate like a gigabyte of cache in your application will take a gigabyte of RAM. there's not getting around that. But if you don't have to, right, you can slice your application into smaller bits, and then native image can significantly, like this is the JIT infrastructure that was cut off, right? The slice of the infrastructure, because to build the, like you have to set up the neti, like for the requests accepting HTTP or something, right? And then you have to have like some sort of processing and routing framework. So you do have to allocate some memory, but quite a bit of the chunk you can just get out of your application because you process that with GraalVM native image. You can also address the throughput and latency in the GraalVM Enterprise Edition, which is a product by Oracle based on the GraalVM open source thing. They're functionally equivalent, right? So you can run the same applications, but the Enterprise Edition differentiates on performance. So the compiler is even better, and it includes some features like here for the native image, you can use G1GC, or you can use profile guided optimizations, which are when you like sort of the same way the JIT gathers the profile and applies that, you can gather the profile like ahead of time. And then you use that when you build your native image and you get an optimized binary, right? So cool. Now I would like to show it to you, right? I would like to show this goodness to you, and we're gonna go to my trusted workstation here. Trusted workstation here. So I will not use any of those. I have a thing that I want to show to more people that I've done before, right? And this is a thing specifically for the native image, right? So I have the workshop about native image, and it goes into the GitHub Šelajev/workshop, and it has some topics about native image here. Oh God, maybe my workstation is not prepared for that. I think I have Micronaut there. But I wanted to show one thing here that I want to show is how simple it is to build native image. Let me just check. I would actually create an application here for you. So we're gonna go into the temp directory, right? Right, and we're gonna do another temp directory, and we're gonna go into another temp directory. So we have an empty directory here, and then we have Micronaut. Very good, very good. So we're gonna have the command line application here, right? And we go into the we are in the primes, right? So it's a normal Micronaut application. It has the primes command. It's a command line application, so it uses the Pico CLI and Micronaut for dependency injection, right? And I'm gonna go into the file here, right? And I'm gonna edit it, and this will be our computer. This will be our business logic. We're gonna compute the prime numbers, right? So we're gonna take the numbers and we determine if it's a prime, and then we're gonna do like a prime sequence, and we have some random, and we're gonna like randomly compute some prime numbers, which is sort of what we want to do, right? How do I exit Vim? Right, very good. Right, and we need to wire this up into this the main file here, right? So I'm going to wire this, and this is a main class here. You can see that this is a primes command, right? That there is a main method, and there are some arguments here that we're gonna just use, right? So this will be my code here. I will just you know what happens? My key mapper, my computer restarted, my key mapper doesn't work. So I normally use caps lock for escape, which is very convenient, and I recommend to everyone. But now it doesn't work. So every time I need to hit escape, I actually turn on the caps lock, which is quite annoying. And we need to delete the test because we changed the functionality. So we can edit the test as well, but this is not necessary, right? Because we are not building production grade applications here. So now we have the application. What it is, it's a command line application that computes prime numbers, and it will compile this, right? You can see that Micronaut actually takes care of some native image configuration. So it is writing out some reflection configuration and the proxy configuration into the JSON files under the meta-inf native image directory. So, which is very good, right? But now what we can do, we can run our application, and we're gonna say that we want one execution, and the limit for the primes will be 100. So if we do like 10 executions, this is like we see more lines, right? So what we can do is we can time this. We can time this command execution, time minus v. No, time. Right. There was some other time, no? Oh, user bin time, right? Right. Why user bin time double v? Yes, very good. So this time command now will output a couple of things. So shows user time, system time, right? The wall clock time. We spend a second computing that for prime numbers, the whole second on this powerful machine. Remember, this is my machine here with tons of CPU available, right? And then it takes 350 megabytes of RAM, the maximum rate and maximum RSS to run this. Now, what I can build the native image out of that, and for that, I will use the native image task within the Micronaut. But what it does essentially, it takes that jar file that we are just running, and it feeds that into the native image utility with some configuration that is necessary for that. So this will take a minute because it needs to actually process the jar file. That is quite a lot of time, and then it is running the compiler on all the code that is actually ending up in our application. I'm going to show you how to do this reflection and other configuration in a minute on a different application, but this is just an example here, right? I think this application will compile like in a minute, maybe a little bit more. It's quite RAM intensive. The biggest part of this is that it needs to build the graph of the whole application, classes, objects, and everything, and then compile all that. So it takes quite a bit of RAM. So if you're gonna do this at home, make sure that you actually provide with a lot of RAM, right? The more, the better. I think like around like 16 gigabytes should be enough, right? 16 gigs should be enough for anyone. Actually, no, I've seen people compile huge applications that result in like the compilation takes almost an hour, and then the binary is something like 500 megabytes. Like truly huge applications. They were like building like on the proper workstations. I know people who were buying like Threadrippers for GraalVM native image compilation, but that is of course excessive. You can always go to the cloud, and it's not that bad. It's not that bad. So don't listen to me here. This is just it's 3 a.m. my time, 4 a.m. my time. So I'm talking nonsense. Everyone has like 6 gigabytes of RAM. My phone has 6 gigabytes of RAM. Right. So we are here, right? So now this is our application, and we can do this actually, right? So we're gonna do this. We're gonna run the build native image application, and we're gonna do the same thing. We have one thing, and we want the limit of 100. Boom, our application is done. Literally, boom, it's done. We initialize the random with the predefined seed. So our, like, if we do more, the actual numbers are comparable, right? But you can see that's one done. If you are interested in the timings of that, user being time minus v, and then the same thing, right? It's very simple, very fast. It takes no time. It takes like 10 milliseconds, and it takes 40 megabytes of RAM. This is almost 10x, right? This is, I don't know, second, like this is 100x. Just think about that. We compiled it, and this is the binary file, right? If I do LDD on this file, what build? No, not here. Like build native image application, right? This is the file that is linked to system libraries. And if I do file, what? No. If I do file this is an elf executable, right? This is an executable file. You can take it, you can put it in the Docker container, and you can just run with it. Like, you need in the Docker container, of course, there's like the system libraries here. But you can also build the statical link binaries if you want to, right? So this gives you like a very rough idea of what is possible, just to amaze you here, which is kind of pretty amazing, actually, to be honest, right? And you can build like complex web applications that are doing complex things, like accessing Kafka, writing to databases, doing some business logic validation, doing XML processing, and so on. You can build those into native executables, and they also start really fast, right? So the more code you need to run, actually initialize, they start a little bit slower, but like a little bit slower means like maybe 40 milliseconds, maybe like 100 milliseconds. And it also depends a little bit of how much CPU you are giving to that. So here's an example. For example, I have my Lambda, right? There is an Amazon Lambda that I built with the GraalVM, with the GraalVM native image. So it's a Micronaut application. Actually, it, like, you'd laugh, but they actually compute the prime numbers. I'm using the prime numbers for everything. This is my business logic. I live to compute prime numbers, which is kind of sort of ridiculous, but also it does simulate the prime numbers quite a bit. So here's our Lambda, and it uses, what is it? It uses the normal memory setting of 520, 12 megabytes of RAM. So it comes like with what, like half a CPU? I think that is half a CPU in AWS, right? So I can do this. I can run a test against that Lambda, right? And you can see if we see the details. This was a cold start. I didn't touch this Lambda before. You can see that it prints the prime numbers from 2 to 100, right? And the init duration of this, the cold start of this thing, was less than a second, like 500 milliseconds. The Java version of this, I have a Java version of this using Java 11. The Java version of this, right? And primes random. Yeah, I think this runs a little bit different code for the primes. It doesn't do 2 to 100, but it does like random between, like a random slice of that. But like it initializes for like 4 seconds in using the same configuration of 500 meg, right? So if this is sometimes not acceptable, you cannot maybe wait for the service for 5 seconds, especially if you have like a chain of services and they're all cold, right? So you need to keep them hot. And the native image, you can probably like 500 milliseconds could be a reasonable time to wait for the service. Maybe not, but this is for you to decide, right? So it does give you the startup advantage. It does give you advantage of operating with a lower memory consumption, right? So this is that. I want to show you like the configuration for the reflection and everything, because it's actually a part that is very often people just misunderstand how easy that is. Like it sounds hard. You're like, you need to configure something and you don't know what your application is actually doing, because who knows what their application is doing? If you know what application, your dependencies, your framework, and the JDK is doing, please type 1 in chat. If you think that you're not quite sure what some of the parts of those things are doing, type 2 in chat. And while I'm just showing this example, right? We're gonna go back to the console here, and we're gonna back out, and we're gonna do the dear reflection, right? So, and we're gonna do CD reflection, and we're gonna do what's the reflection example, reflection example Java. We're gonna paste the code here. Let's look at that. Nobody actually types anything in chat. Oh, you are not listening to me. Oh, I caught you. Not listening. Bruce is saying that he's not 100% sure what the code he's using is doing. That is correct. No people actually know what they like. Very few people know what the code is actually doing, right? So, and what it's using. So here's the reflection example. What we do here is we take the class name, method name input from the arguments, and then we instantiate that class, and then take the declared method and run that method and print out the result. And we have 2 classes here for the choice: the string reverser that will reverse the string, and the string capitalizer that will capitalize the string, right? So we can say like a reflection example, reverse string reverser, reverse, and the string, or string reverser, string capitalizer, capitalize, right? So the business logic is clear. Let's compile that with JVM, right? You'd be surprised, but JVM is also coming from my GraalVM distribution, right? So it's all good. And I can do Java. I'm gonna copy this whole command line here because I'm a little bit lazy, right? We can do this, right? Double Java, 1 Java, right? So we have, oh, Oleg, very good, very good. You can see that works, right? Now, if we will build the native image without any configuration, right? Then when we try to do the same, we will get an exception. We'll get an exception because we did not configure the reflection, right? So it will not include those classes into the binary. So when we say like, oh, reverse the string, it will not find the class, the string reverser, because it's not there, because it was not included, because you can see in the code here, there are no direct references to include this string reverser. There are like this main method is just not referencing that whatsoever, right? So that means we need to provide the configuration. How to do that? Very easy. You have the output directory. We'll make it an output directory as well. And then we're going to run our application on the JVM with the tracing agent, right? This is very important, right? We say that we want to run with a native image agent, and we say the config output directory here, right? And we run the exact same thing that we want to run here. We run the reflection example with the string reverser, reverse hello. Now, if we look at the directory that we created, right? Native image, you can see that there are a bunch of files now, which is the configuration. And the reflection configuration now says that we're going to access the string reverser, and we're going to access the method called reverse with a string. Now, if we build a native image and provide this configuration to it, so the native image configuration like directory will be picked up by default, right? But with this configuration, it will actually include the string reverser into our thing. And moreover, Moreover, we can run the agent again, and we're going to say like, oh, please merge our configuration. So we're going to run a different use case here, and we're going to run the capitalizer, right? And we run the capitalizer. And if we do this cat again, we can see that now we have both reflection configurations in there. So literally to provide the configuration for the reflection or the proxies or the JNI or serialization, what you need to do is, or method handles, what you need to do is you need to run your application using Java with the Java agent and exercise the code paths, which is sort of easy, right? Now let's build this thing. Let's build this thing, and just to show that it works, let's build this thing. Right. It's gonna take a minute again, maybe half a minute because it's just one class, but it needs to process. It needs to process the JDK class library, right? So it needs to process that all the time, which means that it takes a predefined amount of time at least, but it's very quick because look, it gets to the inlining already and it will just run very fast. So in no time, we will be able to run this magnificent application. So what is it? A reflection example. How big is it? How big is it? Reflection example. It's 9 megabytes. Not bad. Not bad. Remember, this is a standalone thing, so it doesn't depend on JDK. It doesn't depend on the JVM. You can put it into like a minimal operating system Docker image, which is like what? Like, I don't know, 15 megabytes. And in 20 megabytes, you can have the application that runs, and it is absolutely perfect. And it can be a tool to reverse strings for reverse string for you. Right, and it works now, right? So the reflection works. Reflection is not a problem. Stuff is not a problem. There are some things that you need to know about native image, the class initialization strategies and how it snapshots the heap, but those are more advanced topics. With the configuration like this, with the tracing agent configuration, most of the application should work. I would still recommend you to use the base framework that is supported for Spring. That means that you have to check out this excellent project called Spring Native, right? If you just Google Spring Native, you can check it out, right? So it's Spring Project Experimentals under that organization, right? And it shows how to build native images. It shows some config, some resources, and how to try it out. A lot of things should work out of the box. With modern Spring Boot, you can build the starters and you can build the database access and some reactive stuff and everything. And it's kind of very, very cool. Right. So we are at the time where I was told that we're going to stop our session. And very briefly, very quickly, I want to touch on the Java on Truffle, right? Which is kind of a very cool thing, is that recently with this release, and I will not show things. I will just talk about this because it's an experimental feature, but it's something very, very exciting. So Java on Truffle is the Java implementation that actually sits here, right? In this picture, right? In this picture, this Java, right? So not just going directly through bytecode through the hotspot facilities, but through the Truffle framework. And it's a JVM implementation, and it's written in Java, so it's a meta circle VM, which is very, very cool, and it gives you a new way to run Java applications. So here GraalVM gives you an option not just to run with the JIT or AAT, but in the JIT you can also say Java minus Truffle, and it will run using the Java on Truffle JVM, and that gives you some interesting, the performance it doesn't give you currently, right? The first release was concentrating on the compatibility and actually being able to run stuff, but it does have a couple of features. For example, the advanced class redefinition, right? In the debug session, the same way as the normal hot swap can do method bodies, the Java and Truffle can do adding, removing methods, constructors, modifiers to those things, lambdas, inner classes, and so on. The fields are currently not supported. We are working on changing access to the changing like the structure of the classes, so adding, removing fields, and it will be available in the later release. But even currently, it is a much more sophisticated.
I'm sorry, I'm still in this meeting, but that's fine.
Yeah, that's fine indeed. We're gonna shortly finish. Worry not, Peter. Right. So the advanced class redefinition, right? You can run the debug session. You can change the code. Your IDE will reload that code in the application on the fly, which is kind of cool. It might not be complete, or it might not be like something that you actually are looking for right now, but it shows that it is more powerful than Hotspot in some regard, right? And another very interesting stuff of that is that the Java and Truffle and the GraalVM JIT, all those are the Java code, right? They're written in Java. So what you can do, you can take the native image and compile them into the binary. So what you can do is you can mix the ahead of time compiled and JIT in the same process here, right? So you can take the Java code and the normal thing, the normal AUT application, and you can compile that to binary, and you can include the Java and Truffle on top of that, and then that will execute you can execute the Java code dynamically within this ahead of time compiled native image, which I think is mind blowing, very, very interesting. But this is experimental and this is very recent, so stay tuned. Just a couple of more slides. The companies are using GraalVM in production here and there, right? Twitter uses that for Scala microservices. They're using specifically the compiler. Oracle Cloud Infrastructure is using for better performance for some cloud services. There was some collaboration with NVIDIA for implementing the CUDA bindings and exposing them as a GraalVM language, which is very, very interesting. And there is a GraalVM Enterprise Edition, which you can purchase from Oracle. It's actually this, like in January, was made a part of Java SE subscription. So if you're a Java SE subscription user, you can use GraalVM Enterprise Edition without additional cost. And you get support, you get a better JIT compiler and everything. So you can just done that. And then there is a polyglot. I wanted to skip the polyglot, right? Where's my, here, yeah. So we can talk about polyglot at another time. But if you just want to use the open source components of the runtime, you can just go to GitHub or the graalvm.org, download and run it. It will still run all the same applications. The compiler is still state-of-the-art compiler. It's a little bit less powerful. The enterprise compiler has additional optimizations and more work put into that. But the GraalVM Community Edition is still showing better performance than OpenJDK in the number of workloads and on average, but it's a little bit more volatile here and there. It still includes the native image capabilities, and still includes the polyglot, so you can run all the same applications. And yeah, you can join the communication and so on. Yeah, so this is it. I managed to run approximately in the same time that I wanted to do this presentation, which is very, very good, I think. We can talk about more. There is polyglot, there is building shared libraries, there is embedding. Yeah, but all the good stuff, but that is probably for another session. Okay. Do we have any questions, or how do we do this? Do we need the...
Yeah, so are there any questions for Oleg here? I'll just toss out one real quick. Do you have to do anything to handle serializable when you're compiling natively, like you have to do with reflection?
Yes. So serialization needs to be configured, and you need to explicitly say, I would serialize and deserialize the classes like A, B, and C, right? So the best way to do that is the the tracing agent as well. So if actually I should have an example for that actually here. I will not run it, but I will just show the serialization, right? So if I want to use the class like that, and I'm here just using something, and I'm serializing a list of long files, right? So I need to serialize list, number, and longs. Then my config native image serialization config. It looks like that. It's a JSON file that literally says that, oh, those classes will be participating in the serialization, right? And that allows the native image to include those and enable serialization, deserialization for those. So yeah, and you generate this with a tracing agent as well, right? So yeah, the answer for that is yes.
Okay, so it's basically that you just list the classes that need to be serializable, and it takes it from there.
Yeah, absolutely.
Okay, great. Does anyone else have any questions?
I have one question. Like to run this with serialization configs and all those things, I saw you are running the main program, and through that it's creating these config files. But what if we are using some libraries like suppose Hibernate or some other libraries, right? For that, how does it will work without running the application?
Right. Without running the application, it will absolutely not work, right? Like, so yeah. To produce the config with the tracing agent, you need to run and execute the code path.
Okay. Okay.
Right? You can. There are two ways. Like, there are three ways actually for this, right? One is you can make the so Hibernate, for example, creates proxies for your model files, right? And it sometimes can access your model through reflection to instantiate those classes, right? Yeah. So you need the configuration for both, right? So one way is you run your application with the tracing agent and you exercise those code paths. For example, you're using your test suite with the tracing agent, and you merge the config that is run with from the tests, right? Hopefully you are actually testing those code paths.
Generate,
and you get and it will generate. The second option is you generate those by hand, and this is the most it's not cumbersome, but it's most like tiring, right? Because you need to really understand that Hibernate will access my stuff through reflection, and this is where the honest answer by Bruce comes to help, because I, for example, don't exactly know what Hibernate is doing. Like I have no idea whether it accesses this through reflection or it does some like unsafe tricks, or like, does it need to generate the proxies for me or not? I can use Hibernate, but I'm not Hibernate expert, right? So it is a little bit challenging to create this by hand. So what you can do, you can maybe generate the config for like some use cases, right? And then you can extrapolate that for like, you probably have like multiple model classes. You can have like a person and a bank account and an address and say movie, right? And then you run the tracing agent and it says like, oh, you need to like the reflection config for the person. And you being a smart developer, you immediately like, of course, yeah, person, Hibernate, right? And then you're like, yeah, I also need to include the other ones. And then you can just like edit this JSON file. And the third option is to use a framework that will provide the configuration for this out of the box for you, right? So for example, Micronaut is using the annotation processing, right? So you annotate your model with the introspected annotation, making it saying that, oh, I know that I would like to like get access to the properties of this class or like the fields and whatnot, right? And it will use annotation processing to generate the classes for that will not actually even use reflection. And the Quarkus, for example, does something similar, right? And then they generate the classes around that, and then they provide the configuration for native image, including that, right? So that is the third option. And this native image configuration, the good thing, actually good thing that you asked, this is just, it can be embedded in the jar files. So for example, Netty jar files include the native image configuration for Netty. So when you are using Netty and you're trying to build native image, you don't have to configure Netty, right? You only have to configure your code, and at worst, you have to configure the boundary between your code and the library code. But you don't have to actually configure the actual library, right? So the libraries can embed that, and the more widespread this is in the ecosystem, the easier it is to get started from the get-go. But for now, I think the best bet is to use the framework that supports native image. That is absolutely the easiest, right? If you have a large application on running on WebLogic or WebSphere, and you're like, I'm gonna feed this to native image, then you will see obstacles on the way, and you will probably not resolve those by yourself. Actually, probably not even with our help, right? But for greenfield projects, absolutely, and absolutely doable.
Okay, thank you.
Very good question.
Thanks.
All right, if there's no more questions here for Oleg, this is usually when we give him a round of applause here for a fantastic presentation here. I really appreciate it. So thank you.
Thank you so much. This was an excellent presentation. I hope the recording will be going out. It's very thought-provoking to improve delivery on containers.
Yeah, containers is where this is really very, very interesting.
Okay, so
thank you for the feedback.
Okay, well, thank you, Oleg. If you want to stick around, the presenter is eligible to win a raffle prize. So what I'm going to do is see if I can right-click here on Ted, if you want to unmute yourself here, and I'll let you run the raffle. And for some reason, it's not, when I right-click on you, it's not giving me the option to make you a host, but you are unmuted and I can see you. What I may need to do is to demote Oleg here. I hate to do that in order to make, no, it doesn't let me do that. That's odd, but I should be able to make Ted the host. It did let me record, however, and I just turned that off a minute ago. So
okay.
Oleg, I think you may need to stop sharing your screen or something in order for me to
I think
switch over or relinquish that right. Oh, there we go. There you are, Ted.
okay.
Now we're good.
Does anybody else want to be in
Take
the
this away.
Does anybody else want to be in the raffle?
Yes, I do.
Okay. I think that was Robert speaking.